we are going to find volumes of solids to end Calc 1. That's kind of where Calc 2 picks up, talks about a lot of different and more advanced methods for integration and things like that. So those of you that just take Calc 2 have that to look forward to. But we want to look at volumes, and we've found volumes in the past, right? We've seen formulas where we have volume of like a sphere, a cube, those kinds of things. Volume is essentially area of the base times the height. So if I give you this figure, capital A represents the area of the base. If you find the area of that, take it times the height, you get the volume of the figure. And we've seen that in the other shapes. Volume of a cylinder, I've always said it's pi r squared h, because the area of the base is a circle, pi r squared times our height. A box, the area of the base, length times width, times the height. So it's all an area of the base times the height. So if I give you some irregularly shaped solid, okay, we could find the volume if we had a formula for the area of this, right? Because the problem with this solid is it's not shaped the same all the way through. So it's not just one area of the base the whole way, right? The area right here, if I took that little piece, would be different than the area over here. So these little slices, they're called cross sections. So think of it as like if I had an object, okay? If I want to find the volume of my little apple here. A cross section is like if you slice it, what are you looking at? So my cross section is a circle here. And so if I wanted the volume of it, I would have to essentially take all those slices, all those areas, and add them together. So that's something that we've kind of talked about before in terms of finding areas, right? When we first did area under curve, we talked about doing rectangles and adding them all up. But we know if we want that to be precise, what has to happen to the number of rectangles? Right. So the same thing here. If I want to be accurate, my cross sections need to be getting more and more frequent, right? I don't just want to take big chunks. I'd have to take small slices. And so that's essentially turning into the sum of those areas. But we would need those to go to infinity. So that leads us to our volume. The volume is the integral from A to B, starting and stopping point, of the area of a cross section. Now, because the area changes throughout, the area is not going to be a number, it's going to be a formula. Okay, and that's what we'll be using to find our volumes.
What's the asterisk?
Oh, x sub I is just saying the i's changing as you go through.
It's like a snowflake.
Okay, so let's take one that you have been given before. Volume of spheres, 4/3 pi r cubed. Right? I told you that all year long. You want to know why now? Let's figure it out. Okay, so here is where my drawing really comes into question, because I am not great at drawing three-dimensional objects. But first, let's just
boxes.
Yes, I can do a box. Outside of that, it's a little sketchy. Okay, so if we have a sphere, pretend like that's like an actual three-dimensional ball. Okay.
How would one even draw that?
I don't know. Therefore, I don't. Ask our art people. How do you draw a sphere other than just a circle?
Like a circle with like a little curve reflection on it.
Caitlin's going to illustrate for us throughout this section.
Oh, okay.
When you don't understand my pictures.
I didn't even understand the explanation.
Okay, so think about like a tennis ball. Alright, if I'm going to find the volume of that ball, a cross section is if I just take that ball and I slice it. So if I cut through that tennis ball, what shape am I looking at? A circle. So can we agree that the cross sections are circular?
Yeah.
Okay, so we need to figure out where we are going to integrate. We have to start here and end here. We know the radius is r. So radius is the distance from the center out. So this x value would be r. What's this one going to be?
Negative r.
So we'll integrate from negative r to positive r. Whatever the area of that cross section is, dr, I guess should say. Alright, so now we have to figure out what's that area. We need a formula for the area. So, if I take my ball, and let's say I slice it right here. Okay, I'm gonna cut that off. So we all know, we can agree we're looking at like a circular thing right there. If I slice it, what would be the area of that green circle that I just drew? What is the area of a circle in general? Pi times whatever the radius is squared. So we need to find the radius of that circle.
Isn't it like just half, 1/2 R? Or are we like actually finding like an actual number?
Yeah, we're finding a formula for it because it's going to change as you go through. Alright, so if I think about this, from here to here, what's that distance? R. Okay, if this is a point on my circle, x, y, then we could think of it as a triangle. Okay, so this is x, this is y. So we know x squared plus y squared equals r squared. The radius of my green circle is y. It's that height that I meant. You guys agree with that?
Mhm.
So if I solve for my y, square root plus and minus, but we're looking at just the positive. So it's the square root of r squared minus x squared. So that is the radius, and that would be my formula that I would put in here. So to find the area at any given point for that cross section. I need to fix something. This should be dx. We're using x as our variable. I kind of switched away from ours. Sorry about that. Okay, so r here is a constant, right? The radius isn't changing, but our x does. So let's simplify. So negative r to r of pi. If I square that, it cancels the square root. Okay, so you can factor out the pi if you want, it's just coefficient. What is the antiderivative of r squared if x is the variable? That means r squared is, that's the derivative.
Oh. 1/3 R.
0.
R to the 3? What is happening?
R is a constant. It's just like a 5.
Oh,
the
you're
antiderivative
adding-
of 5,
you're adding
you
an
add your
x.
x back. Minus the antiderivative of x squared is 1/3 x cubed.
Oh no, we're gonna prove it.
Yeah, that's what we're doing here. Proof. Alright, if I put in my r, I get r cubed minus 1/3 r cubed. Minus, if I put in negative r cubed is 1/3 r cubed. So you get 2/3 r cubed minus negative, so plus 2/3 r cubed. So 4/3 r cubed. Which is 4/3. R cubed.
I was confused on what we were. Oh.
Yeah, so I was just proving that formula that I've told you
I was
the whole
wondering.
time.
I was wondering why Carson said that.
Yeah, so this is why that formula works. We just use calculus to rederive this formula that you've already been given.
Do you think that's how they actually derived it in the first place? Or? They were just doing it. Yeah, they were just like.
I thought he scoffed. He was like, "You think that's how they figured it out?" Like he was there.
Okay, so that one was kind of hard. We're only going to do a few of these today. We're going to take it kind of slow. But we want to look at a few different shapes and see if we can find volume. So this is my attempt at a drawing here.
Oh, did you make that?
I did. Do you like it?
I
It's
did.
like half a trumpet.
Yeah.
Wait,
Are
so
you guys impressed with my artistic ability?
Yeah.
I am. Did you draw this in MS Paint?
I just used Smart Notebook and drew it and then saved it.
yeah, it's just a pen. Oh,
Dude, I was just doing
Glow. Yeah, let's. So what if we do 1/2? What we
Oh, we
just did?
figuring this out ourselves.
Take a second and read it and then we'll look at it.
Oh, it gives us the radius.
The radius is x squared.
Okay. So,
That means
in our
when we
is 0 to 1.
integrate, yep, our limits, we're doing it in terms of x, and I've already told you x starts at 0 and ends at 1, so we're going to go from 0 to 1. Alright, so x is my variable. We have to integrate a cross section, so think about your cross section. If you slice this anywhere, so you can be looking at the end, or if I took a slice back here,
That makes a triangle.
is it a triangle though?
No, it's a
but I
circle,
wanted
or
to
it's a
be-
It's
semi.
a semicircle, so it's half of a circle.
Oh,
So a circle is pi r squared, so half of it will be 1/2 pi. But we know the radius changes depending on where I slice it, right? So we need a formula for the radius. Now, I actually already told you. The radius here is x squared. What this is part of a parabola.
Oh.
Oh, yeah.
So my radius I told you was x squared.
X squared squared.
Oh, there's an extra square.
Yes.
Why is there?
Because the formula for area of circle
Radius.
is
Oh, I
pi times your radius squared, and my radius is x squared.
got it.
All right, so we're going to integrate from 0 to 1. 1/2 times pi, I'll just write that as pi over 2x to the 4th. Okay, so if you want, you can just pull out the pi over 2 or keep it, whatever you're most comfortable with. What's the antiderivative of x to the 4th?
X to the,
1/5
or
x
1/5
to
x
the
to
5th.
the 5th.
So we get pi over 10 times 1 to the 5th minus 0 to the 5th, or pi over 10. So you just found the volume of that figure.
Those are the area formulas? Or do you have to memorize?
Yeah, am I gonna have to like actually?
You should know area of a circle.
What about like all the other ones?
What?
Like your basic areas, like a triangle, rectangle, circle, you should know.
Like we don't do like ovals.
Is
and all
triangle
that.
1/2 base times height? Could it be?
All right,
I feel like
You wanna look at
triangle's
another
gonna look cool.
Yeah.
That's a good triangle.
okay.
It is not a triangle. It's a-
Find the volume of the solid obtained by rotating y equals 1 minus x squared, bounded by y equals 0, around the x-axis.
So we're gonna
So
get
are
a
we
negative.
changing and then the y squared equals the?
Are we gonna have to do that thing we just did where we have
What?
like the?
Let's draw a picture.
Oh,
I think that
have
would
no idea how you even
Yeah, probably.
draw this.
So let's just start. Okay, if I asked you to graph 1 minus x squared, so just plug in some points. If x is 0,
Zero.
you get 1. If x is 1, you get
Oh,
0.
0. If x is negative 1, you get
Zero.
0. So what this is just an upside down parabola. So it looks like that. But then I put some stipulations on it. It's bounded by y equals 0. What's y equals 0?
A line
Which line?
is
The
a.
lower.
The horizontal x-axis. So it's saying we're only looking for the part above that.
Oh,
Anna, did you have questions for me?
No, I got it.
And I'm taking that little piece of a parabola and I'm turning it, I'm rotating it around
You're making a
the
sphere.
x-axis. So I'm making a sphere by doing that. So I am taking this, I really stink, this is where you need Caitlin's art ability, but you are rotating this around. So as it spins around, it's forming a full sphere. So we have a ball. Okay? You guys see that?
yeah.
Alright, so if x is my variable, my limits have to be x value. So I'm starting when x is
Negative 1.
and ending when x is.
1.
Okay? If you look at a cross section, so if you slice this, what shape is it?
Circle.
It's a circle. Area of a circle is,
Pi r
Pi
squared.
squared.
okay, so pi times whatever we get for our radius squared, and x is our variable. So now, let's think about this. If I took my cross section, so let's say if my little cross section was right here. The radius is the distance from the x-axis to that line, right? that then?
We just did it. It's r squared minus x squared.
Well, it's
Oh, it gave
1
us.
minus x squared. It gave us the formula for that line. And that's your radius. Depending on where you're at, your radius is just from the x-axis to that line. So it's forming my radius. Now we've done the hard part. The setup is what's tricky on these. Are there questions about how I got there? So my curve is my radius because that's the height we're looking at. The cross section is a circle, so that's why I'm doing pi r squared. So if you want, you could take out your pi. If I FOIL that, I get 1 minus 2x squared plus x to the 4. Alright, antiderivative of 1
X, right, x.
minus antiderivative of 2x squared,
2/3 x cubed.
antiderivative of x to the 4th.
1/5 x to the 5th.
And we're going to look at that from, negative 1. So now we just plug those in. I put in a 1, minus, put in a negative 1. And what do we,
2 minus 4/3, all times pi. Pi 2 minus 4/3. Oh wait, no, there's multiplication.
I think it's 16 pi over 15. Let's try one more. So find the volume of the solid obtained by rotating about the x-axis, the region under the curve, y equals the square root of x from 0 to 1. So if I draw my picture,
If that always gives us y equals square root of x, is that always our radius?
so if we put in 0, we get 0. If we put in 1, we get 1. We could do more points, but we don't need to because we're just looking at that section. If you start rotating that around the x-axis, what are you forming?
A half circle.
Block,
A cone, yeah.
block cone,
So something.
kind of like a heart.
So it look kind of like this, right? You artists don't judge my abilities here.
Oh, I'm judging.
No, it's pretty sad.
No, you're not an artist, so it's okay.
Yes, ma'am.
Okay. If you look at a cross section, if I take a slice, what shape am I forming?
Circle.
Still a circle.
Yay.
So we integrate from where to where?
From 0 to 1.
Okay, and this is in terms of x. Area of a circle is pi times the radius squared. My radius, if I take my cross section, is just from the x-axis to that curve, and that curve is
Or radical.
Root of
I know what I'm saying. I didn't even say any of those words were the right words.
if you like, you can pull out your pi. So we're just integrating x. So the antiderivative of x. And so you have pi over 2. And we get a volume of pi over 2.
Oh, yeah.
Oh, I didn't see how much homework we had to do.
Syntax.
We can also.
Okay. I don't want to do anything too crazy because I know we're getting ready to have several days off. But I just want to mention a couple more things and then we'll pick up with it on Tuesday. Everything we've done in terms of x. It is possible to integrate in terms of y, just like we did with our areas sometimes. If that's the case, you have to make sure that these are y values on your integral, dy here, and it would be in terms of y. So that is an option. Really, everything we've looked at so far, this is what's called when we're looking at any function, what we're doing is the disk method. There's different methods for finding these intervals, but if we just have a curve, anytime you rotate it around the axis, you're forming something that would have a circular cross section. So that's why all of these, it's pi r squared, because all of their cross sections are circular.
You keep dogging on your ability to draw. That's an amazing face.
Oh, thank you.
It's like the ones they have the sauce potato Mexican restaurants.
Oh, yeah. It does look just like it. Were you hungry whenever you made this?
Apparently.
You had a hankering for Mexican.
So if you're just taking a curve and rotating it around the axis, your cross sections are always circular, and that is the disk method that we've been using. So just pi times your radius squared.
It's a name.
We will look at some in terms of y on Monday, and then talk about the washer method Monday. So if you're rotating two curves at once. So you have a very intense homework assignment for Easter break.
1 and 3?